Imagine your system has been hacked and you have lot of JWT tokens which are still in circulation. How can you stop that? How can you stop the bad actor or the hacker to take undue advantage or misutilize the JWT token which are in circulation? So, if you want to learn about this very important cyber security and identity concept called as auth token revocation, then watch this video till the end and like and subscribe to my channel. So, let's take a use case. Uh, I have a system. Now, this system allows you to transfer money or for that matter you can do any kind of shopping. It's a e-commerce system. I called it as service 1. There is a, and this is a distributed system by the way. So I'm just making this one, but this has lot of small servers behind it, let's imagine. And then you have a API gateway. Now the process is, there is this cute little user with a smile, and then there is this OAuth server. So this user goes there, says, hey, my name is Prem Asim, can I get the JWT so that when I talk to the banking system or my e-commerce system, I would present them the JWT and tell them that I am who I am claiming to be, which is Prem Asim with a valid token. Now this guy would validate the token. So there are several ways of validating which we will learn, but after validating it would allow or deny this access. So this guy can do money transfer transaction or whatever for that matter. So if I have to revoke, for example, this guy got a token. Now we know about JWT, which is JSON Web Token, that once it has been generated, then there is no way, technically there is no way that you can log it out or delete those tokens, or you can control these tokens. So there is a different way of doing that against the traditional way. What was the traditional way? Traditional way, you had this token, probably this is a session ID, I would say. As soon as user logs in, he would get a session ID, and as soon as you want to invalidate this session ID, what you would say against this user, you delete this entry. So next time whenever the user comes and his session is not there, he can't log in or he can't do anything. This system was good, especially it was good when you have to do the revocation kind of stuff. But what was the flaw? This was not distributed. Every time whenever there is a session validation which needs to happen, it would go to a cache or a database, would see if that entry is there for the session ID, and if this is valid or if it has been revoked, it is in logged out and things like that, then come back and this would allow or deny the system resource request. So this thing was okay if there is one server, but if you have a distributed programming way wherein you have lot of small servers, a cluster of servers, then each one has to hit this, there will be multiple requests, and that would increase the latency of the system, which means that the added time to go and check in the database from all over the places, like from all over these servers, was kind of killing, like defeating the purpose. So we had this JWT, wherein as soon as you get the JWT, let me clean this for you. So okay, we can also clean it by selecting some area, so that would be cool. Now the main purpose of this JWT is that at each person, as soon as he knows that the JWT is kind of valid from all over the, like from even from different clusters, S2 which has small servers and S3 whatever, the JWT provides two keys, one for writing which is called as the private key, and second is for validating which is called as the public key. That is what is called as asymmetric algorithm or asymmetric signing signature creation or like so. For doing this, you have a private key and a public key. So long as this guy has the private key, as soon as token comes in, it would validate. If the token is valid, it's not expired. But in between, during that 60-minute lifespan, the issued at and the expired at, if someone hacks the system and they want to revoke it, how would you even do that? For revocation, there are several ways which we will discuss. So first way is, each time when you have to do this, instead of doing the local validation which you are doing with the key, which makes the system very efficient, you get rid of that. Each time you go here, you call the OAuth server, hey guy, is this token valid? And then it would respond true or false, and then you move it. The problem is that when you issue 1 million token, out of those 1 million token, hardly there are 10 tokens which might need to be revoked before it expires. So all the 99.9999% token, they add traffic, they slow down the overall performance. So this is not a very efficient way. The second way is a Redis way. So how you would do that? Let's clean this again. So the Redis way of doing this is, whatever the tokens get revoked, basically, you can put them in a clustered way. We can call it as a Redis, which is clustered. So whenever the local validation is happening at service 1 or service 2, their API gateway or the service would connect to this Redis. And if we will look at the JWT, basically whenever a JWT is being created, there is a token for the JWT, right? Which we call it as the JWT, JID, like the JWT token which can be issued. So based on that, whatever the JWT token is, if that token, you can always mark it as revoked, basically. So once it gets revoked, these are like claims which are in your hand, then you would just say that, hey, this is invalid, so you don't allow it. Now there is a problem in this system. If you have Redis which is clustered, each time still when you are trying to do remote, instead of calling to this guy, what you are trying to do here is you are trying to hit Redis. Of course Redis is way much faster, and since it could be installed like locally to all your service wherever you have the caching, basically, which is clustered, so it would be way much faster. But there is another very good way which is even optimized and faster than that. So let's redraw everything and try to understand. So this way is that I have multiple services. I would call it as service 1, service 2, and service 3, dot 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 dot, on and on. So whenever user comes here and presents his token, to the service, this is OAuth server, what it would do is, like in the token there are claims, so there is a claim called as audience. So whenever someone would invoke the endpoint, the endpoint is called as the token revocation endpoint. I am trying to show you that as well. This endpoint, someone calls here, so it would open the token, it would see what's the audience, and based on the audience, could be service 1, service 2, or service 3, it would call a webhook. Now based on that webhook, if this token's audience was S2, it would invoke here, and then there is a local Redis which will say, hey, this token is invalid, and the TTL for that would be the expiry time. So what would happen with that? That as soon as that time comes, this would get invoked. So if whatever the traffic comes, if this OAuth server generates 10 million token, if this got this got revoked just 2 tokens, so they would be here and they would disappear. Here there might be nothing. So whenever the validation request would come for the token, since the Redis which is installed here, which would be the part of the webhook, so as soon as you revoke the token here, it would invoke the webhook. Hey, service 1 is the audience and this token is revoked. This is local, so during local validation this would be way much faster, and most of the time this would be empty, and when it's empty the request to here to check won't even happen. So you save all this time. Only thing you would have to take care of, you should have the webhook. You can do webhook, or you could also use Kafka in this case. So Kafka would have events whenever, and it would have some topics. So whenever the token revocation would happen, based on whatever is the listener for that topic, it would just put the event there. The listener, like this service, will listen, hey, is there any token which got revoked where the audience is service 1? If nothing, it won't be notified. So that is another system. Instead of calling the webhook, you could do that way. Either way is fine, depending on the cost and the infrastructure and other things you might consider. In the webhook process, the listener has to be active all the time. In the webhook process, listener don't have to like do anything. It's just that once in a while it get revoked, so it might be a little bit less expensive. That's again considering my opinion with a very nominal use case.